Good afternoon. This is Mr. Haas coming to you from Heritage Grove. My afternoon class felt that it would be good for us to do a video of prime factorization, what we learned today on Thursday the 23rd. So I'm going to put together a video on prime factorization really quick and get it up on the web. I apologize, I don't have my trusty tripod, so it's going to be a little bit shaky. Okay, so prime factorization from factor trees. We have the number 36. It's an even number, right? Unless it's an even number, it could be a prime, but if it's an even number, it can't be. So we're going to look and we say, okay, from our rules of divisibility, we know that one of the factors is going to be 2. And I'm going to circle that. Okay. So I've got the number 2. What other factor, in other words, what other number times 2 is going to equal 36? Well, 18 is the number. So 18. Is 18 a prime number? Well, no, because it's an even number. It can't be prime. So the only prime number that's even is the number 2, and that's right over there. But 18 is even, so we know that we can factor it out. And since it's even, we know that we can divide it by 2, which is again another prime number. 2 times what number equals 18? Well, that would be 9. Okay, is 9 a prime number? Well, remember our rules of divisibility. The rules of divisibility say that if this number can be divided by 3, which it can, then it is not prime, it is composite. And this is one of those numbers that we should know pretty well. 3 times 3 equals 9. And both of these are prime because the number 3 is prime. Okay. Now we're going to gather together all these prime numbers that we have, all these factors of the number 36. And they are 2 times 2 times 3 times 3. Okay. Now remember that we want to get the prime factorization. This means that we're going to use those exponents. How many 2's do we have? Well, there are 2 of them. So that means that we have 2 to the second power, or 2 squared. We also have to have 3 in there, a base of 3, and we have 2 of those, so 3 is also squared. So the prime factorization for this particular problem is 2 squared times 3 squared. And let's see, this would be 4. And that would be 9. 4 times 9 is indeed 36. So that's how we do that one. I'll do one more for us. Hang on. Sorry, piece of paper is a little sticky today. Okay. So, how about the number 45? That's not bad. 45. All right, it's an odd number. So we can't use 2 right away, can we? Is it prime? Well, our rules of divisibility say that if we can add these 2 numbers together, 4 plus 5 is 9, and that is divisible by 3. So I'm going to put in the number 3. 3. Okay. What number times 3 equals 45? Well, that's 15. Is 15 prime? I don't know. I think there's numbers that we can get out of it. Let's try. It's not an even number, so we can't do 2. How about if we add 1 plus 5? That's 6, and 6 is divisible by 3. So I'm going to go, all right, 3 out. That's a prime number, so I'll circle it. And the factor that I use for getting 15 is 3 times 5, and 5 is one of my prime numbers. So my prime factorization for 45 is 3 times 3 times 5, or 3 squared times 5. Okay? Let's see if we can sneak one more in just in case. Let's go with 100. 100. It's an even number, so we know that we can divide by 2. 2 times what number? 50. 50 is an even number, so I can again divide by 2. Oh, that's a lousy 2. And 25 times 2 is what equals 50. It's not an even number. It ends in a 5. So we know that it can be divisible by 5. That's from our rules of divisibility. And we know that 25 is 5 times 5. And those are prime. And so my numbers, my prime factors are 2 times 2 times 5 times 5. And the prime factorization, therefore, is 2 squared times 5 squared. Okay, and that's our answer. Okay, very good. And oh, let's check it. Let's see, 2 times 2 is 4, 5 times 5 is 25, 4 times 25 is 100. So we have it right. Thanks for watching. See you in class. Bye.